Hi everyone, now we're going to continue our analysis on multi-phase problems, starting with part C. So we already did our calculation on part A and B, and we know for state 1 it's the liquid phase, and we also know the temperature and volume at state 2. And now we're given the pressure at state 3 is oh, actually, there's a typo, I believe. We fixed this in the homework. It's 0.006 megapascal. So we know that the pressure at state 3 is 0.006, and they want us to know the internal energy, the change in internal energy from state 1 to state 3. And that's basically asking us to find what's U3 minus U1. So that's the change in internal energy from state 1 to state 3. Okay, so if we know all the information about different states, then we can definitely find U3 and U1 and then just do this subtraction. So let's do them separately. So let's first take a look at state 1. So for state 1, we know that P1 is 5 megapascal, and T1 is 360K. And we already know that from part A, at state 1, it's a liquid phase. So instead of going to table D.2, we're actually going to look at table D.4 for compressed liquid. So D.4A, and then from there you can find the internal energy at state 1. If you look at T is equal to 360K, and the internal energy at that temperature is 362.5 kilojoule per kilogram. Okay. Similarly, let's look at the same thing for state 3. We know that P3 is 0.006 megapascal, and we also know that T3 is 360K. Why? Because the entire process is an isotherm process, as we mentioned earlier. So at state 1, 2, 3, the temperature always stays the same. So we know that as well. And also from previous discussion, we know that P saturation is at 0.062195. And that value is actually way bigger than our P3. So P3 is smaller than the P saturation, and that tells us it's in vapor phase. And if you don't think that's convincing, you can also draw a PV diagram. So if we have P and V and our vapor dome, and this is our PV diagram. This is isotherm line. So this is T equals 360K. And we're going to draw our saturation pressure here. That's when P sat. Oh my gosh. So I can't write in this corner. So it's P saturation. This is the dotted line. So that's when P is 0.02195 megapascal. Okay, and our phase at this point is P equals to 0.006, which is way below this P saturation. So let's assume it's somewhere here. So that tells us, I'm going to change the color because it's probably hard to see. So this is our pressure here at 0.006 megapascal. So that's in a vapor phase. Okay? So since it's a vapor phase, that tells us we're going to look at a vapor table. So if you go to table D.3a, and at temperature equals to 360 K, you should find the internal energy for state 3 is equal to 2,497 kilojoule per kilogram. Okay, so if we go back to problem C, it's the change in internal energy, U3 minus U1, and we know U3, internal energy at state 3, and U1, which is internal energy at state 1. We just do our subtraction here. It is 2,497 minus 362.5. That gives us a final answer of 2,134.5 kilojoule per kilogram. So this is our final answer for part C. Okay? And the last part, we need to find the TV diagram for the entire process. So that's actually pretty straightforward because we already know all the different phases and all the temperature. So let's just kind of refresh our memory a little bit. So we know that T1 is equal to T2 and it's equal to T3. It's 360K. Okay, and for different phases, at 1 it's liquid, and at 2 it's saturated vapor, and at 3 it's vapor. Okay, so okay, I just noticed that I wrote vapor wrong, so I'm going to erase that, and so vapor. Okay, so on a TV diagram, how are we going to draw that? So let's take a look. So TV and our vapor dome, and so this is our, let me draw a isotherm line. So all these processes, they all have a temperature of 360K. Right, so that means all of these processes should be on this line. And since the first process start with liquid, so we're going to start from left. Liquid, so state 1, it's a liquid, and then we go inside of the vapor dome and stops at state 2 because that's a saturated vapor. And then we keep going, go into the vapor phase. That's where state 3 is. So that's our TV diagram. And that's the end of this problem. And I hope you enjoy this and think this is helpful. Thank you.